Okay, so today we're gonna go over the first question, mystery linked list on week 4. So first, before we begin, let's just talk about what an SL list is. An SL list stands for a singly linked list. So it means your linked list only goes in one direction, and it's not like a double linked list where you have pointers both to like if this is a node and this is another node, we don't have both a pointer to that node and the node before it. And so, like I said, it's a linked list. And in this particular question, each node is an int node, which basically means it holds an integer. And the list has a value that we store in this dot value and a pointer to the next node, which we store in this dot next. And each SL list also has a sentinel node, which is essentially a dummy node that points to the start of our SL list. And just a quick note that it doesn't matter what value is in the sentinel node's value field, it's just a dummy node. So you can put whatever value you want there. Okay, so let's go read the question and figure out what we're supposed to do. So it says, define a procedure of multiples that returns an SL list containing the elements at indices k, k plus j, and k plus 2 times j, and so forth to the end of the list. And then we have some code here, and then we have some skeleton code that I've written out for the multiples procedure. Okay, so we can see that we're starting at the first index k, and then we're going to add to whatever we're going to add to the list that multiples returns. We're going to add every multiple of plus j to k. So let's go through an example just to make sure we understand what's going on. Okay, so I have this singly linked list here, and it has the elements 1, 2, 3, 4, 5, and a sentinel node. And so let's figure out what happens when we call multiples 0, 2. And so we can see that our k value is 0, and then our j value is 2. So when we first start our multiples, we have this pointer to 1, and our k value is 0. So we know that we should put the first value in this SL list. We should put the first value in our SL list in the SL list that multiples returns. So we have a 1 over here. And then we add 2 to k. So k plus j is 0 plus 2, which is 2. So that means we jump forward 2 elements in this list. And so if we move this pointer forward 1 and then 2, we arrive at 3. So we know the next element we need to put in the SL list that multiples returns is 2, or 3. The second element, 3. So that's why we have a 3 here. And then, so we increment this by another j. So k plus 2j, which would be 0 plus 4, which is 4. And then, so we know to move our pointer forward by 2 more steps, 1 and 2. We arrive at the 4th indexed element, which is 5. And so that's why we have a 5 over here. And then at that point, there are no more elements in our singly linked list, so we can just end, and then we just have the last node 5 with no pointer to a next node. Okay, cool. So now that we know, we kind of have a general sense of what our method is supposed to do, we can start writing our code. So at the very beginning, we need a pointer to this node. Remember how we started at the sorry, remember how we started at the first element of our singly linked list. So we want to have a pointer to that. And this node is, well, we can look, we have a sentinel over here, and then the sentinel will have a value and a next. So to get this, we just do this dot sentinel dot next. Okay, and then we want to get to the first kth element, right? Because the first element we want to add to whatever multiples returns is k. And so to get to the kth element, we can use a for loop to jump k elements forward. And here in our example, k is 0, so we don't have to jump forward anything. But if, for example, k was like 1, then we would have to jump this pointer one step forward over to 2. But in the example I wrote out, k is just 0, so we don't need to do that. Okay, so how do we iterate through to get to k elements? Well, we can just start a counter for int I equals 0. And then we want to jump through k elements, right? So we can do I less than k. But we have a little caveat here where, like, say, what if we had k equals 1 and then we just had like k equals 2 and then we just had one element in our list, then if we tried to jump 2 elements forward, we would be hitting a null case, and we don't want to do that. We want to stop jumping k elements forward if there is like no next element. So we can add something to our condition that we check in our for loop, that our node isn't equal to null. Because if our node is equal to null, then we can't jump forward anymore and we should just stop. And then finally, we have I++ to increment the counter. Okay, and then inside our for loop, what do we want to do? Well, we know we want to move, this pointer forward k elements. So we should just set it to node.next so that we can keep moving it forward. Okay, cool. So we have node equals node.next. Cool. And then now we can think, what are the next steps we need to do? Well, we've already put our pointer to the kth element of the list. Sorry about that. To the kth element of the list. So now what we should do, well, we have to return an SO list at the end. So maybe we should go around creating that SO list. We're gonna append each element to first. So let's do that. So list multiples equals new SO list. Cool. Remember, we use the new keyword to create like a new element, like a new SL list or a new int node. We use the new keyword. Okay, and what's the next thing we need to do? Well, we need to know when we go through and we append to our multiples list that we're returning, we want to have a pointer to the next node so that we know so that we can append something to it. So like, for example, in this example, when we got to this element and we wanted to append it to our result, we needed a pointer to sentinel.next so that we could append this one node over here. So let's make a pointer to that. Let's call it int node target equals multiples dot sentinel. Okay, and then we know that whenever we want to append an element to this multiples list, all we do is we can set it equal to multiples.next. Or sorry, target.next, because target is the it node variable. Okay, and so now what we want to do is we want to keep iterating and we want to keep jumping j elements forward until we reach a node where there is nothing pointing to the next. So what we can do, remember node is our node that we're currently at in the given SL list. So what we can do is we can keep iterating until node is equal to null. So while node is not equal to null. And then we have, so we're at a node that we want to add to our SL list, the multiples SL list. So what we can do is we can create a new int node with the value. So like we would create a new int node with the value 1, and then we append that to our target, our multiples list, the list that we're going to return. So what we can do is we can create a new node, and then we can create a new int node with the value of the node in it. So like here, it would be the value of 1, here it would be 3, and here it would be 5. So, and that's in our node variable. So we would do node.value null. And what do we want to set it equal to? Well, remember how we said that we want to append it to the end of our multiples list. And so right now we have a target. So what we can do is we can set target.next equal to this new int node that we just created. Cool. And then what do we need to do now? Well, we can't just leave our target pointer over here to target.next because we have no way of appending 3 to the end of 1. So what we can do is we can move our target pointer forward by 1 so that we have space so that we can append a new element to the end of our SL list. So let's do that. Let's move our target forward by 1. Target equals target dot next. Okay, cool. And what do we need to do now? Well, now we know that we need to jump j elements forward, right? We need to move our node pointer j elements forward to the next element that we want to the next multiple that we want to add to our multiples list. And how do we iterate j elements forward? Well, we can do something similar to what we did over here when we moved k elements forward. But this time we're going to put a j here instead of a k so that we can move j elements forward. So let's do that. For int I equals 0, I less than j. And remember, we still need to do the same null check that we did up here because it's possible that we don't have any more elements to iterate through over here and we don't want to continue iterating if we're at a null node. So I less than j and node not equal to null I plus plus. So that will keep iterating to the jth element. And then what do we want to do? Well, we want to keep moving to the next node. So similar to what we did over here, we just want to keep moving to node.next. Okay, cool. So we've written most of this. And what's the final thing we need to do? Well, we know our method returns an SL list. And we've created our SL list over here. and then we've appended to it using our target pointer. So what we should do is we should return this multiples list at the end, just by doing return multiples. Cool. And then I guess we can just run through the code really quickly to make sure that it works with our example. So first, we start off with node equals this.sentinel.next. So our node pointer would be over here, right? Just like this arrow indicates. And then for I equals 0, I less than k, node not equals to null, that's true. Node equals null, node.next. Now k in this example is 0. So we're not going to move forward any steps, and we're just going to stay here. Okay, and then we create a new SL list multiple over here. And then our target is multiples.sentinel, so this one. Right, and then so while node not equal to null, target.next equals new int node. So what we do is we create this node. It's a new int node, and then we copy the value of 1 into it. And then we assign it to target.next so that we append to the end of our multiples list. Okay, and then we want to iterate j elements forward, right? So it keeps on going, in our case, 2 elements forward. So this will move 1, 2 steps forward. Whoops. 2 steps forward to 3, right? And because it's a while loop, we keep on going until this condition is true. So until this condition isn't true. And so our node isn't null, so we keep on going through this while loop. We create a new node with the value 3 in it. We append it to target here. And then we keep iterating through until, so we move 2 more steps forward because we've iterated 2 steps forward over here. And then, so let's see. So we move this pointer 2 steps forward over to 5. And then we similarly create a new node. We append it to multiples, right? And then over here, we see that we can't actually move this node pointer forward anymore because we're going to hit null. So if we move this pointer forward 1 more, so if we just move it forward 1 more, then node will be equal to null. Node will be equal to null because there's no more of the SL list. And then so when we go back to this case in the while loop, then node not equal to null will be false. So then we just exit this while loop and we return multiples. And so we see that everything, our code, works out with our example. So yeah, that's MysteryLinkedList, and see you next time.